Now let's look at 2017, question 2, part B. So we've got two ships here, one ship moving north and a second ship is, we're just told it's 10 kilometers west of P. So, and we're given its relative distance. Let's have a little look and see how we can lay this out then. So we have two ships here. Okay, this is P, that's going north at 15 kilometers an hour. And this is Q, and it's 10 kilometers west. So we'll just put the distance in black so you can see it there. 10 kilometers west. And we know that this guy here is moving with the direction of this one 60 degrees. This is V of Q relative to P. All right, and that equals 15 root 3. Okay, so just a small bit annoying, but nothing too weird or wonderful. We know that the velocity of Q relative to P is the velocity of Q minus the velocity of P. So we're asked in part 1 to find the velocity of Q, so we'll just do a quick rearrange. Velocity of Q is VQP plus VP. All right, so that's not so bad. Next step, we're going to get these guys in I's and J's. So we know that VP is nice and easy. That is 15J. This is going north, 0 I's. VQP is a little bit more annoying. All right. So I want to do a small little sketch here on the side. That's 60 degrees. 15 root 3. And we have our I component and our J component over there. It's going to cross, it's going to go down. So it's going to be plus I and minus J. So it is going to be 15 root 3 by 60 cos I. That's right. Cos 60 I minus 15 root 3 sine of 60 J. All right. Now we'll do a little bit of rearranging and putting values in for that. 15 root 3, and this is by a half. I minus 15 root 3, root 3 over 2, J. Okay, so let's bring these all together. So we know that VQ is VQP plus VP. So that is 15 root 3 over 2I minus, now do a little bit of time on this one, it's going to be 45 over 2. 45 over 2 J plus 15J. Okay, we can see it's nice and tidy. Our I's and J's are over here, and that is going to equal 15 root 3I over 2 minus 15 over 2J. Okay, now like all of these things, we need to work this out in a magnitude and direction as well. So we'll come back up here for this one. The magnitude of VQ is square root 15 root 3 over 2 plus 15 over 2 squared, and that, well, a small bit messy, is going to equal square root of 675 over 4 plus 225 over 4. And you can see this is beginning to look a little bit less ugly. It's the root of 900 over 4. Square root of 225, which of course is 15. All right, 15 kilometers per hour, because that's our units here. Direction, well, let's draw us a little picture. It is going to be plus I minus j. So we are going across by 15 root 3 over 2. We are going down by 15 over 2. So we'll call this angle, I'm going to call this beta, because we're actually going to use alpha and theta later on. So that's beta there. So tan of beta, as we'll use a bit of space up here. Tan of beta is opposite over adjacent. 15 over 2 over 15 root 3 over 2. Lots of common stuff going on here. And that is going to equal, dividing everything by 15 over 2, 1 over root 3. So beta equals tan inverse 1 over root 3. And if we punch that in, you realize that beta is 30 degrees. Okay, strictly speaking, it is 30 degrees south of east. Okay, because it's kind of going eastwards, but a little bit south. So there is our direction, there is our magnitude, and there it is, slightly sliced, as our i's and j's. Now let's turn to the second part of question 2, 2017, part B, part 2. 2 minutes after the time they're closest together, P is east 30 theta degrees north of Q. Well, that is an absolute bloody mouthful. If you're having a little bit of a oh my god moment, that's fine. So when we look at a question like this that seems apparently horrible, let's draw it out. So first things first, well, we know that Q and P, okay, P was there, Q was there, and Q was east of P, which means directly to the left, and it was 10 kilometers east of it. What else do we know in this one? Well, we know the relative velocity. So, velocity of QP, all right, was going off down this direction, okay, equals 15 root 3, and it was going at 60 degrees. So that's actually a fair bit of information. Now, if we go back to our question, 2 minutes after the time when they're closest together. So we'll park the 2 minutes for the moment. Let's look at when they're closest. Well, that is going to be here. Okay. Perpendicular at that point there, we'll give it a little name. We're going to call this or is when they're closest. All right. Closest. So what can we figure out? Well, can we begin to figure out how far away this one is? We can, all right. So the sine of 60 degrees is the opposite over the hypotenuse, which is 10. So let's figure this, let's draw this one out now. The sine of 60 equals ORP, which is our opposite, over 10. So ORP, which we wouldn't mind knowing, is 10 sine 60. Equals 10 root 3 over 2. So ORP is 5 root 3 kilometers. Okay, I'll write that into our little diagram here. 5 root 3. Now we're kind of getting places a small bit. So we are interested in what happens 2 minutes after this point. So again, let's pop over here. It's 2 minutes of the ship, they go pretty slow, so it's not going to go too far, and we will call this T. So 2 minutes after or. Well, how far did it go? Handy enough because we know how fast it's going. So for ORT, equals, well, it's going at, okay, now for RT, well, it's going at 15 root 3 kilometers an hour, and we are going to look at 2 minutes out of 60 minutes in the hour. So we work all that out. Okay, and this is going to come out to root 3 over 2 kilometers. So pop this in here, root 3 over 2. Grand, so now we know how far that is. What's it actually asking us for though? We are told about their relative positions, so let's draw some pictures. There we go. You draw that absolutely better than I will. Ship Q is theta degrees. Okay, so this is kind of a bit annoying. P is theta east, east theta degrees north. All right, so it's this angle in here. Terribly annoying because we haven't got this angle anywhere. However, let's have a little look around, because we can see with corresponding angles that that's going to be 60. So we've got this and we've got this. We've got a ton of information in here. So actually what we're going to do, and I'm really wishing I wrote this on the other side, but we won't worry about that too much for the moment, is we are going to call this little angle in here alpha. All right, now what we know is that alpha plus theta plus 60 equals 180. All right, because it's just all around a straight angle. So we're looking for theta. Theta is going to be 180 minus 60 minus alpha, which of course is 120 minus alpha. All right, so that's what we're going to aim to do. So now our whole problem has broken down to finding this little angle. We have that, we have that. Well, this isn't quite so freaky, is it? Because the tan of alpha is the opposite over the adjacent. So tan of alpha equals 5 root 3 over root 3 over 2. Okay, lose the root 3's, equals 5 over 1 over 2. Be a little bit careful on this one. And 5 divided by a half is going to be, of course, 10. Stick in your calculator if you're not sure about that one. That might seem a little bit odd, but that's fine. These ones kind of happen. So alpha is the tan inverse of 10. If you're ever unsure about those weird, straight, bigger numbers like that, stick them in the calculator and see what happens. What you find out is it does happen with very big angles. And of course, alpha comes out to 84.3 degrees. Okay, coming back up to our equation here, bring this down. Theta is 120 minus 84.3. So theta equals 35.7 degrees. So it looked horrible, but actually it was all the normal stuff we do, just tucked away inside a slightly weird story. So now we'll come to the last bit of 2017 question 2 part B, which is part 3. This is back to a little bit more what we're kind of used to. We have a ship here, we have our Q, we have our P, we have our closest distance at or. If Q can be seen from P for 12 minutes, find the distance between P and Q at the end of this time. Well, that was the closest distance, just to remind ourselves. So we came out 6 minutes this way and 6 minutes that way. So let's figure out a little point down here, S, which is 6 minutes after or. Okay, 12 divided by 2. Well, that's not so bad. Or S was going at 15 root 3 kilometers per hour, given that, by 6 over 60. Okay, so that is 15 root 3 by 1 over 10, which course is 1.5 root 3 kilometers. Okay, so that was 1.5 root 3, there to there. If we go back to the earlier part of our question, we see that this guy here is 5 root 3. And we are interested in that distance there. Okay, distance between the two ships at the end of the time. And we're just at Pythagoras. All right, so we are looking for PS squared is 5 root 3 squared plus 1.5 root 3 squared. Okay, you can knock it all into a calculator. If you want a small exercise of getting used to doing these things, that's 25 by 3, which is 75, plus 1.5 by 3, which is 2.25 by 3. I'm going to do all that in one go, which is 75, plus the 6.75. Okay, and that becomes 81.75. It's going to be a little bit bigger than 9. So PS is the square root of that. If you put that all through, it comes into 9.04 kilometers. And there we have it. Or stick that in your calculator and you'll get that. Happy days.